plus 1 by v is equal to 1 by f, or u by v plus u by u plus u by v is equal to u by f, and 1 plus 1 by m is equal to u by f, or 1 by m is equal to u by f minus 1, and m is equal to f by u minus f. Given object distance and focal length, we can write magnification straight away. Therefore, in the present case, magnification is u is 30 centimeter, focal length is 20 centimeter. Therefore, 20 by 30 minus 20, that is equal to 2. Magnification in this case is 2. That value we substitute here, minus 4 into VOX. VOX is minus 5i. VOX is minus 5i, we substitute here, plus 1 plus m square is 4, 1 plus 4 is 5, and VMX is 10i meters per second. So therefore, velocity of the image is 20i plus 50i, that is 70i meters per second. So velocity of the image with respect to ground is 70i meters per second. Means it is going to be towards positive x direction with a velocity 70 meters per second. Now, what is the velocity with relative to object? In case if we want to calculate the velocity with respect to object, Vix minus Vox, that is equal to Viox, that is velocity of the image with relative to object. So what is Vix? Vix is 70i minus Vox is minus 5i, that is Viox, that is equal to 75i meters per second. So velocity of the image with relative to the object, it is going to be 75i meters per second. Next, what is the velocity of the image with relative to observer? In that case, velocity of the image with respect to observer along the x-axis is velocity of the image minus velocity of the observer. Velocity of the image is with respect to ground is 70i minus Vpx is minus 8i, that is 78i meters per second. So like that, by using this idea, we can calculate the velocity of the image with respect to observer, with respect to ground, or with respect to object. Now, what is the longitudinal magnification in the case of a mirror? Longitudinal magnification. Let an object be, extended object be somewhere here, length of the object be L0, and focal length of the mirror be F, and let the distance of the object, okay, UA be the near end of the object from the pole of the mirror, and UB corresponding to the rear end of the object. Means let the object of length L be along the principal axis, and A is at a distance UA from the pole, B end of the object is at a distance UB. What we do is, A as a point object, we calculate the image. So 1 by UA plus 1 by VA is 1 by F. That is the formula. From this we calculate VA. And next one, similarly, B as a point object, we calculate the image distance. 1 by UB plus 1 by VB is equal to 1 by F. In both these cases, we are assuming A distance and B distance from the pole is more than focal length. Therefore, real image is formed. In such case, second case, we can calculate VB distance. So, given UA and F, we are able to locate VB and VA. So, since UA object distance is closer, relatively VA will be greater than VB. Therefore, image distance is VA minus VB is the image distance. So therefore, we can calculate the image distance corresponding to the object distance lying along the principal axis. The magnification in this case, it is called longitudinal magnification. It is equal to Li by Lo. That is the longitudinal magnification. In case object is smaller linear object, very small linear object is placed along the principal axis. In such cases, you can use differentiation as 1 by xo plus 1 by xi is equal to 1 by f with relative, assuming mirror is fixed. So therefore, dxo by dt by xo square is equal to dxi by dt by xi square. So dxi by dxo we can write minus xi by xo whole square. Minus sign indicates the image will be reversed. That is, A will be occurring somewhere here, maybe occurring somewhere here, A dash and B dash may be occurring here. Image will be inverted. So therefore, this negative sign. And this is longitudinal magnification is minus of transverse magnification square. Minus sign indicates the reversion of the sign of the object, means if the object AB is lying like this, image will be B dash, A dash, that negative sign. And the magnification, longitudinal magnification is square of the transverse magnification. Xi by xo is transverse magnification. Square of the transverse magnification. This is valid only in the case of small linear object. Very small linear object case, we can use this formula. Whereas not so small, considerable amount of object is there. Just now I have explained L0 and Li you can calculate the transverse longitudinal magnification. Let us consider an example how we can use this idea to calculate the image. Let a concave mirror of radius of curvature 20 centimeters. Let it be a U-shaped wire, of the height here 2 centimeters, here it is 5 centimeter, and here it is 2 centimeter. So altogether 9 centimeter wire bent in the form of a letter U is placed on the principal axis such that it is at a distance 20 centimeter from the mirror, pole of the mirror. Now 15 centimeter from the pole of the mirror, we will take 15 centimeter from the pole of the mirror. So what about the image? First thing is, we consider this as the object, extended object, call it as some AB, some EF. EF and EAB we consider, these two are the linear objects which are perpendicular to it. So object AB is of height 2 meters, object distance AB distance is 15 centimeter. Therefore, 1 by 15, 1 by U plus 1 by V is equal to 1 by F. 1 by F is 10 centimeter, radius of curvature is 20 centimeters, focal length is 10 centimeters. Therefore, image distance of this object AB comes out to be 1 by V1 is 1 by 10 minus 1 by 15. V1 is equal to 15 minus 10. 1 by V1 is 150. Therefore, V1 is 30 centimeter. So, image is at 30 centimeter distance, but object is between focus and center of curvature. Therefore, real object, image will be real. Real image in the case of concave mirror is inverted. This is inverted image with magnification 30 by 15 is 2. 2 magnification 2. Image will be now formed at 30 centimeter distance. Since it is 15 centimeter, 30 centimeter distance will be somewhere here. This distance, therefore, image will have a length of 4 centimeter. The reason is magnification is 2. And it is inverted, formed at a distance 30 centimeter from the pole of the mirror, and this becomes B dash A dash. Image appears to be like this. Next, what about EF? EF object distance is 20 centimeter, which happens to be the radius of curvature. Object is at the center of curvature. Naturally, say radius of curvature 20 centimeters means this distance is center of curvature. Object is at center of curvature. Image also will be formed at the center of curvature. Image is real and inverted. Therefore, here itself, image will be formed of the same size. Therefore, E dash, F dash will be formed. The distance is 2 centimeter only. There is no magnification because position of the object is at the center of curvature of the mirror. For the center of curvature of the mirror, object is at the center of curvature of the mirror. Image also will be formed at the same place with the same magnification inverted. So, inverted image of this EF will be formed. So, therefore, the distance between these two now will be 30 centimeter minus 20. Therefore, this is 10 centimeter. E dash B dash distance is 10 centimeter. Therefore, total length of the image of the wire length is 2 to 4 plus 5, 9 centimeter wire in the form of U, letter U bent and placed on the principal axis. Now it appears to be like this letter, like the wire will be appearing as the image will appear to be like this inverted image, and total length of the image is here 2 centimeter plus this is 10 centimeter plus this is 4 centimeter. So, 16 centimeter length image will be formed for the corresponding to object length 9 centimeter. That is how we can calculate the images corresponding to the object positions.
ఇది ఇవాల్టి ఫిజిక్స్ క్లాస్. ఈనాటి ఎపిసోడ్లో రిఫ్లెక్షన్ ఆఫ్ లైట్ ఆన్ స్పెరికల్ మిర్రర్కు సంబంధించిన కాన్వెక్స్ లెన్స్ గురించి తెలుసుకున్నాం కదా. రేపటి ఎపిసోడ్లో ఇదే టాపిక్కు సంబంధించిన మరిన్ని అంశాలను తెలుసుకుందాం. టిల్ దెన్ కీప్ వాచింగ్ KAB టెలివిజన్.